All right, 14.2, name this quadrilateral. So they give us four coordinates, 4 points, and they want to know what type of quadrilateral it is. So the first thing I'm going to do is I'm going to name all these points, A, B, C, and D. And I'm going to give a rough sketch of, about where these points are. I'm going to use quadrants 1 and 4 because I have no negative x values, so those are all on the right side of in the coordinate plane. So 0, 0 obviously is right here at the origin. 4, 3 is probably right about here. 13, negative 9, a little further, and probably down somewhere over here. And then 9, negative 12 is going to be back a bit and down a bit farther. So this looks like it's probably going to be a rectangle, but I need to prove that. And so before I can even get to the point of proving that it's a rectangle, I need to prove that it's a parallelogram, right? That's the sort of the parent shape of a rectangle. So to do that, I have a couple ways of proving that. One way is proving that opposite sides are parallel, so that AD is parallel to BC and AB is parallel to DC. I do notice that later on, I'm going to have to find the perimeter and area. So I think actually distance is probably going to be maybe a little bit less work, although if I want to show it's a rectangle, I will have to show that adjacent sides are perpendicular. So that will involve finding the slope, but let's just find the distance first. So to show it's a parallelogram, I need to show that the measure of AB is equal to the measure of CD, and I need to show that the measure of AD is equal to the measure of BC. Right, these are both our pairs of opposite sides. Both pairs of opposite sides are congruent. Okay, so to do that, we're going to use our distance formula. So if I want to find the distance from A to B, right, I need to find my change of x squared plus my change of y squared, and then that'll be equal to the distance of AB squared, right? Really, if I'm looking at AB, right, I'm making sort of a right triangle here, and I'm taking the change in x, the change in y, and that'll give me my actual length of AB. So from A to B, we're going 4. All right, and it's actually really not important if you want to go from B to A or A to B, right? Either +4 or -4. Either way, we're squaring that number, so it could be positive or negative. It does not matter. The result will be the same. The change in y is 3, and that's equal to the measure of AB squared. All right, I already recognize this to be a Pythagorean triplet, so I know AB is going to be 5, but I'll just show the work in case we don't remember what that is. A Pythagorean triplet is when you can put 4 integers in for the Pythagorean theorem. So this is going to be equal to 25, and that's equal to AB squared. So square root both sides, we get 5 is equal to AB. So this is, a decent amount of work, because we got to do this 4 times. CD, change in x squared plus change in y squared equals CD squared. All right, so from C to D, I'm going from 13 to 9. That's a difference of 4. And it doesn't matter if I write 4 or -4, remember? Either way, it's going to be positive. My y is going from -9 to -12. That's a difference of 3 between those two numbers. And that'll be equal to CD squared. All right, and again, I'm not going to do all this work again because I can see these numbers are exactly the same, so I know I'm just going to get 5 is equal to CD. All right, save myself a little bit of work here. And I already showed the exact work, so I wouldn't lose credit for that. Okay. Now we're going to do AD. Okay, so AD is going to be from 0 to 9 is my change in x. So, sorry, let me write my formula at the top first. Always good to do that. Change in x from 0 to 9 is 9. From 0 to negative 12 is 12. That's equal to AD squared. So we get 81 plus 144 equals AD squared. 81 plus 144 is 225. And we actually have another Pythagorean triplet here because 225 is just 15 squared. So hopefully this other side works out just as easily. We're finding BC now. Just section off my work so it's very clear. Okay, same formula for distance. And all right, if these were horizontal or vertical lines, it would make our lives a lot easier because then we could just, just count the boxes over. But we have diagonal lines here, so we have to use the Pythagorean theorem. So from B to C, we see from 4 to 13, that's a change of 9, so 9 squared. From 3 to negative 9, 3 minus 3 is 0, then minus another 9 brings us down there, so 3 and 9 altogether is 12. That's equal to BC squared. And remember, if this is something that you can't do in your head, obviously I've had plenty of years of practice. If I wanted to find the difference between these two, I could just do 3 minus negative 9, and that would give me 12. That's hard to do in your head. Always tricky when you're going from positive to negative. So I can see already, I have the same exact setup I had here, so I know 15 is going to be equal to BC. So, have proven A, B, C, D is a parallelogram. The only thing left is to prove to be rectangle, one pair adjacent sides are perpendicular. So I need to show that if I take the slope of, let's say AB, that's going to be equal to the negative reciprocal of the slope of BC. All right, we're flipping it over, negating it. Those two should be equal. So let's find those two slopes. The slope of AB, if we find change in y over change in x, and it's actually kind of convenient because we already did this. For AB, we find the change in y over change in x is 3 over 4. And really here, it is a little bit more important what's positive and what's negative. Because as you can see, sign matters when we're talking about slope. So really, I shouldn't have actually checked there. I should have gone back to my original and seen 0 to 4 is plus 4, 0 to 3 is plus 3. So I clearly know that my change in y over change in x is 3 over 4. And now let's do the same thing. So this is equal to the slope of AB. It's equal to 3 over 4. Slope of BC. Okay, so let's go from B to C. And here I'm actually going to stack my coordinates so that it's way more obvious. Because it is a little trickier when you're dealing with negatives and positives. So to go from 4 to 13, that's plus 9. That's my change in x. My change in y from 3 down to negative 9 is minus 12. So that'll be minus 12 over 9. Both these numbers have a common factor of 3. So I divide both by 3 to reduce my fraction, and that's just negative 4 over 3, which is the negative reciprocal of 3 over 4. So I can say that AB is perpendicular to BC. So we know that ABCD must be a rectangle. It's not a square because adjacent sides are not congruent. And it's not a rhombus for the same reason. And it's got to be a rectangle. All right, so find the perimeter. Well, that's pretty easy. 5 plus 5 plus 15 plus 15. We're just adding up all the sides, and that is equal to 40. The area is just length times width, so any two adjacent sides, so 5 times 15, and that will bring us to 65. Is that right? It doesn't sound right. Yeah, 75, that's right. 5 times 10 is 50, 5 times 5 is 25, 50 plus 25 is 75. Good.